Problem 1. So we're just solving for n. So I'm see the parentheses there with the number outside. So I distribute through. So I have 4n plus 4 equals 4n plus 4. Well, right away I can see the two are equal to one another. But let's say we solve it. We go ahead and move the 4n over. And I get 4 equals, that goes away. And it goes away here too. The n's all disappear. And we end up with 4 equals 4. Now, is that always true or never true? That's always true. That means, if it's always true, that means there's an infinite number of solutions for n. There's an infinite number of solutions. Because back here, basically the two equations are the same. So no matter what you plug into n, you're going to get the same answer. If I plug in 5, I'll get 24 on the left and 24 on the right. If I plug in 7, I'll get 32 on the left, 32 on the right. So there's an infinite number of solutions. No matter what you plug in for n, it's going to work. That happens whenever you solve it and you end up getting the variables disappear and you get a true statement like 4 equals 4. That's true. So there's an infinite number of solutions. Here, well, we solve it. We subtract 3n from both sides. I get negative 1 equals 5. Is that ever true? That's never true. That never happens. That means there's no solution here. Okay, if it's a false statement, you're going to have no solutions because no matter what you plug in, if you do 3 times a number and take away 1, you'll never get it to equal 3 times that number plus 5. I mean, if you have some number and you're taking away 1 and then you're adding 5, are those answers ever going to be equal? Never. So no matter what you do, there's no solution. Again, when you get some statement that is false, you know there's no solution. Problem 3, well, I must combine things over here on the right. I get 5n plus 3. Right away, I can sort of see never, if I do 5 times the number and add 1, is it going to ever equal 5 times the number plus 3? But if we solve this, we can see that what happens is we get a false statement. And if you have a false statement that's not true, that means there is no solution. No solution at all. Number 4, well, over on the right, I need to distribute. 2n minus 10 equals distribute through 2n minus 10. That's always true, isn't it? And again, if you subtract 2n from both sides, you end up getting negative 10 equals negative 10, a true statement. Just like we know 2 times the number minus 10 will always equal 2 times the number minus 10 because it's the same thing. That means there's an infinite number of solutions. In other words, no matter what I plug into n, it's going to be true. If I plug in 1, I'll get negative 8 on the left and negative 8 on the right. So there's an infinite number of solutions. Okay. There's problems 1 through 4.